Logistic regression is pretty common in the OT literature, and that's because in OT we have a lot of questions that have yes or no answers. We want to know, does some intervention make it more or less likely that somebody's going to get a job or return to prison or read at grade level or recover full hand function? And these are all yes-no kinds of questions. And that's what logistic regression is for. So it takes one or more predictor variables and makes a prediction about what we call a dichotomous outcome variable, something that has a yes or no answer. So linear regression, if you remember, that's looking at a interval or ratio data on the x-axis predicting some sort of interval or ratio data on the y-axis. Logistic regression, the data looks like this. So for some x variable, we have either yes or we have no, and there's nothing in between. So you get this kind of relationship. So it's impossible to draw a straight line that fits this data. So what logistic regression does is it uses something called the logit function. That's where logistic comes from. What they're doing is they're taking this curvy equation and they're taking the log of it and making it a straight line so that they can treat it with the same sort of linear equations that we liked from algebra. Y equals slope times x plus intercept. And in a really important point, this is a probability. This is log odds. So this is telling you the odds of something happening, not the probability. And the distinction is important. So in casual conversation, people often use the words odds and probability interchangeably, and they have a distinct difference. So the odds is a ratio of the number of ways an event can occur over the number of ways it can not occur. Probability is the number of ways an event can occur divided by all the possible things that can happen. So the odds of rolling a 6 on a dice is 1 in 5. The probability of rolling a 6 is 1 out of 6. So when you're looking at a logistic regression equation, it's going to be written probably exactly the same as a linear regression equation. So you need to know going in whether it's linear or logistic. Once you do, when you're trying to interpret what do these betas mean, if this is some sort of continuous, so this is years of education, for example, some sort of continuous is variable, an increase of 1 year in education increases your odds of getting a job or not going back to prison or not going back on drugs by beta 1. If this is some sort of dichotomous variable, so it's a yes or no kind of thing, so was a veteran or not, was previously incarcerated or not, graduated high school or not, the way to interpret it is, if this is true, the odds of Y happening are increased by beta 1. And what the probability, the p-values that you're getting are telling you is what's the probability that this beta is actually 0. So regardless of how much this changes, if this is 0, it has no influence on Y. So what's the probability that this really is 0 and has no influence on y.